Hello everyone, and this is Computer Vision Streams. I'm your host Anton. Today we continue to learn about Jetson platform services, and the use case of this video would be about vision language model video summarization. We will go through this tutorial and we will see how we can re-implement this use case, but using only large language models hosted locally. The first thing, why we are interested in video summarization, because we have a lot of video data that is not processed in any meaningful way, and there are a lot of value to be created from improving our methods of using this data. According to some estimations, more than 99% of all CCTV camera videos are never processed in any meaningful way, but we can extract a lot of patterns and a lot of useful ideas that could improve our lives. How the summarization service from Nvidia sample is working. So first, it will accept a video file, and then it will split video file into frames, and frames will be batched into chunks in some way. Then each chunk will be summarized with either vision language model from Nvidia or a GPT-4o model from OpenAI. So in this case, because we want to run our sample locally, we will use VILA language model from Nvidia. After we get the caption for each batch of frames, we can then use some other language model. In the original sample it was GPT-4. In our sample it will be OLLAMA with LLama model 3.2 to make a summary of captions of different frames, and then we can collect all the summaries of different batches of frames and make another summarization for the whole video, which will be done with GPT-4, or in our case with LLama 3.2. So overall we have multiple calls to different large language models. First, vision language model to caption frames, and then 2 calls to make summarization. Let's see what kind of prompts Nvidia propose in the example. So we have a system prompt that is quite basic. You are a helpful assistant. Then for image captioning, we have a prompt that asks to examine these video frames and provide a detailed, accurate description of observable actions. Focus exclusively on visible activity without making inferences or assumptions. Remember, these frames capture the same person over time, not different individuals. Be concise and precise in your description. Everything is good in these frames, except that we see that we ask model specifically to concentrate on one person and that it is exactly the same person on the video. I think it is because that this demo was done with a specific video in mind, and in order to reuse this sample for another use cases, we need to rework those prompts. The next prompt is caption summary prompt. Provide a high-level summarization of the entire video, focusing on overall activity. Use the provided summaries of continuous video chunks to inform your summary. Do not analyze each scene individually. Basic summarization activity. And for the whole summary, analyze the frame-by-frame descriptions of human activities below. Summarize the continuous activity into a single, cohesive sentence, starting with the subject. Captions may contain errors, so ignore captions that are less frequently mentioned in the overall description. Avoid generating unreal or unsure interactions by disregarding any relevant information about human activity. So basically here we see that it's again a specific prompt for some specific sample video that included activity of one human being. The summarization model will still work at some level for other videos, and we will see what it generated for a video of road traffic. But in any way, to do some meaningful product from that, we will work a lot to change prompts, to fine-tune prompts for our use case. So the first setup, because we want to make inference locally, we need to set up something to replace GPT-4 for summarization. And I like to use OLLAMA server for local inference. First, we can install and download OLLAMA service, which will install it as a systemd service. We can change, because we make inference on Jetson device, and I run OLLAMA at my local PC, so I had to change OLLAMA host to accept API calls from other devices. To do that, we can use environment variable OLLAMA host, and to restart the server, we either can add OLLAMA host to the description of a systemd service, or to stop systemd service and restart OLLAMA serve separately. After that, we can use the command OLLAMA run and the name of the model that you can find. All different models you will be able to find on their website, which is quite neat and simple to use. After running those commands locally, we can use this curl command to check if our service is available on local API, and we can see it effectively returns some question, so we can continue to work with our Jetson device and deploy other services. So first is to run some of the basic Jetson services, for example here Redis for storing results of summarization. Next, we need to provide the configuration for our services, and in order to use a local inference, I make some modifications to API key, base URL, and the model name. You can find configuration in the repository associated with this YouTube video. Afterwards, we need to download a Docker image that is called VLM Summarization, and also you will find a Docker file that I used to make an update of OpenAI client, because apparently in the latest demo of Nvidia, OpenAI client is quite old, and to use other compatible interfaces, we need to make some modifications. Also, the repository contains main and config.py file that contains some modification to the inference call for our OLLAMA inference server. We pass our configuration file, we override main.py and config.py, and also pass a couple of folders with videos and for caching downloaded models from Hugging Face. Let's start our VLM summarization Docker file. In order to see logs and to check when our service will be ready, we need to use command docker logs -f and the name of the container, and we will see that it will take some time to prepare quantization of the model, and afterwards we will see that our server is running on port 19,000. After 5 minutes, we can see that our server is running, and we can check the documentation for our video summarization API. where we can upload new video files or live stream IDs, and also ask our server to summarize one of the uploaded videos. And get the summarization when it will be ready. Now we can upload one of the video files that is located locally on a Jetson device. This call will return the file ID. We can copy it to the video ID variable, or we can retrieve this video ID using this command, given the assumption that we only have one video file for now. We retrieve exactly the same ID. Then we can ask our API to summarize this video ID, which is not stream, with a visual language model VILA that was deployed locally, with a chunk duration of 20 frames. In the logs of our server, we see that there is OpenCV GStreamer pipeline that starts to extract frames from the video. It will split the video into chunks. Then with vision language model, each frame of the chunk will be captioned. And with LLama3.2 model deployed on OLLAMA, it will be summarized. And then the whole video will be a summarization of the summary of small chunks of that video. So here we are starting to see first captions of the frames. Which describes this video of people walking near the road and of different vehicles going through the road. And we will see what kind of summary we can generate for this generic video without any specific events of interest. So we can have some useful facts. A school bus drives on the road, individuals walk on the sidewalk, cars drive on the road. But to extract some more specific and maybe geographically located events, that might require first prompt engineering, or maybe even a fine-tuning for specific types of events. And here, interesting point that we can observe: a blue school bus with a number and the word school written on its side is seen driving on the road. We have a blue school bus. We know that it should be an anomaly, and if we consult the video, effectively we have the number 27B and the word school written on the bus, which is quite nice and shows OCR capabilities of the vision language model. But what about blue school bus? Is it a bug of the vision model, or it's a bug of our preparation pipeline? If we take a look at another observation, several individuals, including the one wearing a yellow hat, are walking on the sidewalk. But we see that the halo hat of individual is actually blue. And if we know our knowledge of color representation, we will find out that yellow color and the blue color is exactly opposite when you switch from RGB to BGR representation of a color. That means that somewhere in the pipeline of frame extractions in the sample provided by Nvidia, we operate on the BGR frames, and the model receives BGR frames. But because vision language models, they're usually trained on RGB frames, we need to ensure that they will consume RGB frames when we try to make a summary. So this is definitely a bug for the demo, and it is very common error in computer vision systems when different libraries and different models accept different representation of a color, and we need to ensure that they are coherent between different modules. So after the model processed the different batches of images, it provided a final summary, and the final summary we can extract separately by using summarize endpoint. Let's see what we can get. We can use JQ command to organize our JSON response a little bit better. So final summary. Here is a high-level summarization of the video. The video captures a typical day in a bustling city. It shows individuals walking on sidewalks, alongside busy roads lined with greenery, buildings, and vibrant colors. Not too useful, maybe because the prompt was generic, or because the prompt was about some person's activity. So definitely we can improve upon that. And also there was not a specific anomaly that we can highlight on this video, so the description of the video is correct. The question is how we can extract value from those kind of description, but that will be a subject of another video. In this video we walked through video summarization demo of Nvidia Jetson services that used VILA visual language model and LLama3.2 hosted on OLLAMA inference server to make some summarization on a Jetson device. There are a lot of improvements to do upon this demo in terms of model loading and model caching, prompt engineering, and fine-tuning for your specific use case. Thank you for your attention. You will find all the necessary code in the repository in the description of this video, and I will see you in the next one.